Yeah.
Good evening, everybody. I'm architect Namrata Mahal. I welcome you all for the 22nd webinar today here, and I would like to thank Tata Tiscon for having this beautiful series. I have been watching this and I'm privileged to be here today. Thank you so much. So before we move on to the presentation, I would request you all to please keep your microphone on mute mode and your mobiles on silent, and you got to be attentive for just 50 minutes. So I'm going to complete my presentation in 50 minutes, and 10 minutes we keep for the question and answer round. So the outline of the presentation is we are going to understand what exactly green buildings or green homes are. Then we are going to understand what are the norms that qualify for a green building, and what is this GRIHA, the national rating system, what are the variants of GRIHA, the rating process, the structure, and we are going to address two very important questions. That is, do we have to do any additional work, and do we pay anything extra? With that, we move on to the main presentation. But before that, you got to tell me where is this place from. So in the chat box, you can quickly type in what do you feel this place is from, which part of the country. See, it's a webinar and it's, I'm in a very beautiful room in a beautiful setup, but I don't see you people out there. But we got to interact like this, like you type your answers in the chat box and I get to see what is the answer. Wow. So Aman Jain is saying that this place is from Kutch. Absolutely correct. And what made us say that? If we look at the image more carefully, we see circular wall, we see thatch roof, and very beautiful painting over there. That makes us say that this place is from Kutch. And it's a traditional house. The next one. This is not moving. Yes, so the next image, this is from, you got 2 seconds to answer this. It's a village, Kerala, Goa. Okay, Vivek, you're right. When you say Kerala, yes. So what make us say that it is from Kerala or Goa, or for that matter, any coastal city? Because of the sloping roof that we see, the laterite stone, and very interestingly, someone has typed tree. I see a coconut tree, exactly. So this place is somewhere in a coastal city. This one? Oh, we got an instant answer. It's Hawa Mahal from Jaipur. Perfect. Now the next one is very, very easy for you to answer. The one on my left. We got 2, 3, 4 seconds to answer this. Mumbai? Okay, wow. I'm from Mumbai. I did not see this building. So Rohan, it's maybe in Mumbai, not very sure. Okay, let's make an attempt for the building in my left. Perch. Okay. Yatharth is saying it's from Perch. Okay. So we have somebody saying even Singapore, Dubai. Okay. Why are we finding it so difficult to locate this building? These are our modern architecture buildings. We are taking time to identify this because you see there's over here. If you look at the previous image, if I say that Hawa Mahal is probably in Srinagar, you will say that I've gone out of my head, to say that. Unlike for this building, we can debate for hours to say like, this is from Mumbai or Sri Lanka or Singapore, any place, Let's go inside today and see whether these buildings are really comfortable or no. This is how it looks. There's a lot of heat and grace, and one can't even work on the mobile phone. Forget about working on desktop. One can't even see the cell phone. And then we are forced to switch on the artificial lighting and put on the air conditioning system, which again adds to the energy load and to our pockets too. So in GRIHA, we emphasize that a good design is just not about aesthetics, but a well thought combination of climate responsive elements, good living environment, and the culture that we are rich in. But then how do we know all this is actually happening? If I have to ask you a question that, are you healthy? You will probably say, yeah, I am healthy, I'm fit. But if I ask you further, what makes you say that you're healthy? You would probably say that, I am 58 kgs, my BP is normal. So do you realize there's a number associated here when you say you're healthy? Same is the case with our buildings. Unless you don't measure it, you won't understand how green you are. So when we conceptualized GRIHA, we based ourselves on very strongly on the existing codes and bylaws that we had. So Terry, the Energy and Resources Institute, had conceptualized this rating system, GRIHA. GRIHA stands for Green Rating for Integrated Habitat Assessment. Basically, it is a point-based rating tool that will help you design, construct, operate, and measure the greenness of your building. And the council that monitors, administers all this is GRIHA Council. So if you look at the timeline, we had fabulously seen progress, with a lot of municipalities and municipal corporations, state bodies adopting the rating system, endorsing it. But I would like to draw your attention to the bottommost, which is the INDC document, nationally determined contribution. So every year there is a conference that happens, So now we are in the 26th year. So COP 26 is going to be happening soon, where every country makes a commitment. And in the year 2015, India had made a commitment in terms of signing the Paris Agreement, where they said that we would reduce our carbon emissions by 35% from the 2005 levels. When they said that, they highlighted only GRIHA. Here, I want to emphasize that they highlighted only GRIHA as a national tool through which they would reduce their emissions from the building and construction industry. So GRIHA, depending on the scale of your project, you can register in any of the variants of GRIHA. Like in new buildings, we have 4 categories. We have SWGRIHA, GRIHA for large developments, and GRIHA for affordable housing, which is based on the PMAY scheme of the Government of India. In existing building segment, we have GRIHA EB. EB stands for existing building. We have a specially designed rating system for day schools, and we have GRIHA for cities also, civic bodies governing towns, industries, existing and new settlements. So today, since the webinar series is focusing on individual homes, we are going to look in depth this SWGRIHA rating system. Now, if you look at this house that is seen on your screen, it is so beautiful. I would definitely, being an architect, I would definitely want to design and live in such a house, which would have probably minimal impact on the environment or probably zero also in some case. This is another beautiful example. Do you think these buildings would really be having any impact on the environment? Can we have a quick poll of yes or no? Okay, so there are a few people saying no. Okay, I get a yes also. Okay, so when we look in isolation, probably these buildings may or may not have an impact. But what if this is the case? If you see now, every house in the city is of a smaller scale, but cumulative, when we look at it, it's definitely going to have a major impact on the resources, on the environment. It is definitely going to have a detrimental impact. That's why we thought that we should have a rating system for these smaller units, for these individual homes, these individual bungalows. So we designed this SWGRIHA rating system, which is simple, versatile, affordable GRIHA. So it's a design cum rating tool. It has got 14 criteria and a point weightage of 50 marks. We'll come to, again, this point scoring and all of it in due course. Let's quickly understand the rating process. So one has to register the project online on our website, which is www.grihaindia.org. Once you register the project, you get an option whether you want to have an orientation workshop or no. So with the entire team, we sit and we discuss all the 14 criteria and what is the target of the project to achieve is what has been discussed during this workshop. Then one has to submit the document online, and then a final visit is conducted on site to understand that whatever you have committed on paper, whether you have already you have executed the same thing on the site or no, and then you get the final rating. As soon as you register, you get access to this tool. So this is a design come rating tool. So the moment you pay our fee, you get access to this tool. If you look at the threshold categories, so there are 5 sections: the landscape, architecture and energy, water and waste, materials and lifestyle. So at the moment you see that the threshold met is being shown as cross because you haven't attempted any points. So this tool will prompt you, this tool will give you feedbacks as in how you have to progress with the whole rating. So if I click on the first criterion, which talks about the urban heat island effect, it's very simple. Even a non-technical person can just fill in the details and calculate that how green his or her building is. Suppose if you're confused that what kind of passive design strategies I need to implement, it's very simple. On this tool, you have to just select the climatic zone and you will get a list of design strategies that you can implement in your project. Now you don't have to worry about any data. For example, if you want to build or you want to construct a rainwater harvesting tank, simply what you have to do, get into this calculator. You don't have to even fill the rainfall of your region. You have to just select the location. You have to put the total population size. And if you look at the bottom, the volume is being calculated for you. So this is the volume that you have to design your rainwater harvesting tank for. So it's very simple, very user friendly. So these are the broad sections, 5 sections that we have, and this is the scoring. Now the catch here is, unlike in GRIHA, the main rating system, where we have mandatory clauses, here we don't have mandatory clauses, but we have mandatory points. So for example, in landscape, the total point weightage is 6 marks. You got to score at least 3 marks, which means that out of 50, your project needs to qualify at least for 25 marks. And then depending on the scoring, you get either 1 star, 2 star, 3 star, or the highest star is 5-star rating. So when you score above 46 marks out of 50, you get a 5-star rating. Now, should we move to the actual section? So let's talk about landscape. So the first criterion talks about reduce exposed hard paved surface on site and maintain native vegetation cover on site. Now it is for very obvious reason that we want to reduce the urban heat island effect. Now what is this UHIE effect? Now we have experienced this, that in cities everything is concretized. So in the daytime, these concretized surface absorb the heat, and in the night time they radiate it back. And when you compare the day and the night temperatures with the peri-urban area, you would due to lack of vegetation, water bodies, and all of these sponges, due to absence of these sponging areas, you will see that there is a temperature difference of 3 to 10 degrees. It's a very common phenomena in urban areas, and we have personally also experienced it. Whenever we are looking for a parking area, we always look for shade, right? Why? Because the car is going to absorb all the heat, and then we sit in the car, it's like a micro oven, So that's why same applies to your project site also. We have to ensure that it doesn't become like a microwave, but it is a very comfortable area to live. The second most obvious reason to have the ratio being maintained of the soft and the hard paved area is for urban flooding. Now, this is a image of 2005 where, the Mumbai was flooded, and the same thing was repeated in 2015 as well. Now, the reason for this is because we have very less pervious areas. Most of our surfaces are concretized, so we do not allow the heat to escape, we do not allow the water to percolate down. So for that reason, we say that at least 50% of the total paved area should be either soft paved, it should be shaded, or it should be coated with high SRI paint. Now SRI stands for solar reflective index. Now how do you calculate the total paved area? It's very simple. You take your entire site area and you minus the building footprint area and the landscape area. Now, whatever is the leftover area should either be shaded or it should be having high SRI paint or coating on it. And this is a beautiful example where you see that the driveway has been shaded by the native trees existing already on the site. Now you have to be very logical. In GRIHA, if you see, we haven't invented anything new. In fact, it's a framework which tells you to be a little more logical in what you do. Now this is a car park area. Now I don't need hard paved area in the entire car park area. Only my tires need to rest on the hard paved area. So this is a beautiful example where rest of the area, if you see, is grass, and only where the tires are going to land is a hard paved area. That's how you balance your hard and soft paved area on the site. Again, a beautiful example of grass pavers being seen on the slide. Now, the second part of the first criteria, which has again a weightage of 4 points, where we say that you preserve and protect trees on site. If you have existing trees on site, during construction, you have to ensure that you're protecting each and every tree existing on your site. Now, if you don't have trees, that means that you've got to plant new trees because you have to maintain the microclimate of your own small little plot. Now, depending on your site area, if your site area is less than or equal to 250 square meters, you need to plant 2 trees. And depending, as you see on the screen, depending on your site areas, you need to plant additional trees on site. And you have to plant native trees because the water consumption for native trees is almost negligible as compared to exotic species. Now we'll just quickly recap. When you treat your hard paved areas, you get 2 points. When you preserve your mature trees on site, you get 2 points. And if you have additional tree plantation being done on your site, you get additional 1 point. That makes it total 4. And if there are no trees and you're planting more trees on your site, you get 4 points. With that, we move to the architecture and energy section. Now we are going to talk about passive architectural design and systems, which has a weightage of 4 points. Now, why are we going to have passive design strategies integrated in our design so that we have better thermal comfort and we reduce our overall energy consumption? And also, we are going to talk about low energy heating and cooling system for the same reason that thermally the occupants need to be comfortable. Now the tool is as I showed you in the previous slides, the tool will prompt you with design strategies. Now, if we take an example of hot and dry climate, then you see that the strategies have been listed down. You can have a courtyard, you can have wind towers, you can have earth warming, and all of this can be integrated in your design, which will fetch you 2 points. Now, this is the internal courtyard being designed to ensure that there is natural ventilation happening, green living wall. Now, this is a very beautiful project of GRIHA in the northern part of the country. So if you look at this building, it has got pergolas, it has got beautiful balconies which are shading, and I want to draw your attention to this detail. So these are inverted pots which have been laid during the slab casting, which thermally makes the building more comfortable and reduces the load on the energy consumption. When we talk about energy cooling and heating system, there are a lot of things that you can do. The best way to do and the easiest way to do is to have a BE 5-star rated fan installed in your building. And of course, you can have design strategies also, like you can have your solar chimney to draw the heat and then the natural ventilation happening in, as you see in the diagram there. So these are the low energy cooling and heating strategies which will fetch you 2 points. So overall, this criteria has got a point weightage of 4 points. We move on to criterion 3, which talks about good fenestration design for reducing direct heat gain and glare while maximizing daylight penetration. So the point weightage here is 6. Now we need good fenestration design for 2 reasons. One, that we cut down the direct heat gain and we bring good daylight inside. Now, how do we do this? Now, this is dependent on 3 aspects. First, how have you oriented your windows? Second, how are you shading your windows? And third, what is the glass specification that you are giving? So these are the 3 major aspects which will determine that how much heat is going to come inside your building. Now the formula to calculate this is very simple. So your window area into the insulation number into the SHGC of the fenestration. Now insulation numbers you can get from SP41. It is a special publication from BIS, Bureau of Indian Standards. And SHGC is the value that you'll get from the manufacturer. SHGC stands for solar heat gain coefficient. Now to simply explain you, basically it is, so SHGC would range somewhere below 1. So it's a numerical number below 1. Now if I say that the SHGC of the glass is 0.45, it means that if outside the radiation is 100%, your glass is allowing only 45% inside. So 0.45 is the factor, solar heat gain factor, which means that 45% of the solar radiation is going to enter the space. Now we have also heard about the term called U value. Now what is U value? U value is the rate of heat flow through a unit area building component through an overall unit temperature difference between the outside and the inside temperature. Now I'll explain you with an example what is more important. Generally you have heard architects and designers talking about the U value and not much about the SHGC value is being emphasized more and not the U value. Why? Because the SHGC has got more impact when you're designing the fenestration. Let's see here. Now, if the solar incident energy is 800 watt and the temperature differential is 20 degrees, inside I'm having a temperature of 18 degrees and outside my temperature is, say for instance, 38 degrees. Then if I look at the SHGC of the glass, which is 0.3, which means that 30% of the heat is going to come inside. So it is 0.3 into 800 if I do, it is 240 watts. And if we look at the U value of the glass, which is 3, which means that the difference in the temperature is going to allow some amount of heat to come inside my space. So which is 3 into 20, which is 60 watts. So total heat gain because of the window design and the glass specification is going to be 300 watts. So my SHGC plays a major role more than the U value. So when you are designing your window, you do emphasize on the lower SHGC. And then you can beautifully design your windows if you know what shading device needs to be in place and what is the glass specification that you're going to have. Second part of the same criteria talks about how much daylight we are inviting inside the space. So we are saying that we have to maximize the daylighting inside our space. So one way of doing it is through simulation. You see the daylight analysis over here. The simulation has been done. And the other simple way to do is that, if you look at the plan, the window 1 meter on either side and 2 times the height of that. So in the plan, if you see, this is the daylit area. So you have to just ensure that your entire space, at least 90%, if you're really looking for making a green building, you should ensure that, more than 75 to 80% should be daylit. And this is a beautiful GRIHA project where you see that the windows have been designed at the corners so that the maximum light comes on the flooring and not actually on the bed. Because then if the light is more on the bed, you will end up putting the curtains down and then the whole purpose gets defeated. This is another beautiful example where you see that a lot of daylight is coming and not the heat. Now, can you quickly tell me which is a good option? Is the picture 1 a good option to design or is the picture 2 a good option to design? And we have got 3 seconds for this. Oh, 1, 2, 1, 2. Oh my God, so random I'm getting the answers. Superb. So everybody is active. Thank you so much. So let's see which is a good option. So here in the first picture, we have the WWR. Now what does WWR means? WWR is window to wall ratio. So in the first image, if you see, I want to have the daylight on my working desk. So in the first image, it is very brightly coming on my desk. In image 2, the light is also coming on the floor. That means with daylight, I'm also inviting excess of glare, which is not required. So in GRIHA, we say that the window to wall ratio should not exceed more than 60% of your gross wall area. Now, this is again mandatory in ECBC. So there are, as I said in the beginning, that there are codes and bylaws that we have already integrated in the GRIHA rating system, which made it so easy for the government agencies to endorse and adopt it. So what is mandatory here? That you have to have your window to wall ratio less than 60% and your SRR, skylight to roof ratio, should be less than 5%. And then depending on how much reduction you're showing and how much is your daylight zone percentage, you get points. So the maximum points one can achieve here is 6. Moving on to criterion 4, which talks about efficient artificial lighting system, you get 2 points over here. Now here you have a direct benefit, it's very logical that if I have efficient systems being installed in my house, I'm going to have direct energy savings and my light bills, my energy bills are going to go down. So here we say that so there is something called as LPD. So one has to calculate the LPD, don't get confused, light power density. Here it is very simple. The total connected load of your artificial lighting needs to be divided by your built up area. And this has to be lesser than what has been prescribed in GRIHA. Again, it is as per the ECBC norms. So if you see, if it is an office building, then your LPD should be less than 10.8 watt per square meter. Now you don't have to calculate anything. You have to just feed in the details in the calculator and on its own, it will calculate for you. So if you have this ECBC compliance being shown, you get 2 points over here. These are few site images where you see efficient fan being installed, efficient lighting being installed, and that's a B 5-star rated air conditioning unit. Now moving on to criterion 5, we are talking about thermal efficiency of building envelope, where you can score 2 points. Now, the better the thermal efficiency, the better is the thermal comfort of the space. Now, the thermal efficiency again depends on 3 aspects. One is your wall, second is your glazing, and third is the roof. Everything needs to be well insulated or well designed so that the thermal comfort is maintained. So this is the wall assembly, the glass specification, and your roof should also be insulated. When all of this is in place, then your requirement of conditioning or heating goes down drastically. Now, here in GRIHA, we have defined certain thresholds. Now, suppose if you are talking about a case of Mumbai, then your threshold is 325 square feet per TR. Now, if you show, now this means this is, if I have to put it simply, it means that whatever is my conditioning system being designed, I should, in 1 TR, I should be covering 325 square feet area. Now, if my building is very well designed and the thermal efficiency is very good, I may, instead of having 1 TR requirement for 325 square feet, I can go to 400, 450 also. So more the area gets covered, that means very well efficiently your building has been designed, and you get maximum points under this. So maximum point one can get is 2 points over here. Moving on to criteria 6, use of energy efficient appliances. You get 3 points here. Here we are promoting B star rated appliances. So one is your fan has to be B star rated, your air conditioning system, and the geysers. So now here, all of the 3 installed should either be 3-star rated. Now, if you say I have 10 fans, out of which 2 are 5-star rated and 8 are 3-star rated, then you will get 1 point. Here, the all word is very important. All your appliances should be either 3-star, 4-star, or 5-star, depending on what point score you are targeting. So if everything installed in the house is 5-star rated, you get the full marks, which is 3 points. Now we talk about use of renewable energy on site, which is criterion number 7, where you can fetch 4 points. Now, depending on the built up area, you have to have minimum sizing of the RE system. Now, if your plot area, so in GRIHA, the maximum eligibility of the project is in terms of built up area is 2,500 square meter. If you cross this built up area, then you have to register your project under GRIHA, which is the main rating system where you have 31 criteria instead of 14. So we know we have options like you have solar PV systems, you can have a hybrid system, you can have small wind towers that you see. So this is a police training school. Now, second part talks about the hot water requirement of your project. Now, depending on the typology, whether it's a small hospital, restaurant, or it's a bungalow, you have to cater to the LPD that has been shown here. So you have to ensure that you are designing your building so that at least 50 or more of your daily requirement of hot water is met through solar hot water system. And if it is more than 75%, you get the full 2 points. If it is equivalent to 50% or more, then you get 1 point. And for PV system, for renewable energy system, you get 2 points. So total here we have 4 points in the rating system. Now here there is a non-applicability. Now GRIHA, as I said, we are a very logical rating system. So we also have something called as applicability check. Now something is not applicable to your project, that doesn't mean that you are going to, your point scoring is going to get affected. Now in case it's a hot office building, then you do not have a requirement of solar hot water heating system. So in that case, the 2 points get removed from the denominator. So now instead of getting evaluated out of 50 points, your project would be evaluated out of 48 points. So basically it's a percentile based rating system. Moving on to the next section, which is water and waste. Criterion 8 talks about reduction in building and landscape water demand, for which we have got 5 points. Now in GRIHA, we always make a base case for anything. So now in SWGRIHA, these base cases are already been created in the tool, but I'll just like to, highlight how we work on this. So basically your building is compared with a worst case of your own building. So now in this case, if you see, we are talking about the landscape water requirement. Now your worst case or the baseline case is assuming that 100% of your landscape area is lawn. And we all know that lawn consumes maximum water, right? As compared to trees, mature trees. Have you ever seen somebody watering a banyan tree? No, probably, right? So that's what lawn is a worst case, and planting native trees is a good case for us, as a good practice. So we don't say that you shouldn't have lawn at all. So you can have a combination. So as you see on the screen, in the proposed case, we have few native trees, we have native shrubs, we have patch of lawn area also. Now the water requirement is calculated based on your base case. And this is all fed in the tool. Now here the intent is to minimize your lawn area, maximize the tree cover, maximize the shrub area. Then grouping of plants can be done. So suppose your trees are going to consume very little water, you group them together so their water requirement can be calculated accordingly. Then we also encourage innovative concepts, like you must have heard about xeriscaping. Xeriscaping is basically a dry landscape where you have plants like, which require almost negligible water for their growth. Like you have cactus, you have this, you have pebbles and stones. So it's basically a dry landscaping, what I call. So that can be practiced. Then you can have water efficient systems in place to ensure that whatever is your water requirement is being met efficiently. Not that you're manually watering the plant and you have absolutely no clue that when you had kept the tap on. Generally that is considered as a not so good practice. Here on the screen we see that all native mature trees have been preserved, and on the extreme right you see the drip irrigation being laid. So again, a good practice. Now talking about the water fixtures that are installed in the building. Do you remember seeing the first image of 1970s? There was this, I'm forgetting the name of the movie, but this kind of a system was shown in a movie, when I had to tell to my kids, like, look, we had this kind of a system, and they were just laughing on me, mom, like, which part of the country did you belong to? But these were very, very cute little systems. But if you look at the water saving potential, they were absolutely bad. Like in one flush, we would waste around 15 liters of water. And now we have some so efficient systems, like you have the dual flush, where your water requirement is drastically reduced to 50%. You know, it's like the smaller flush will just consume probably 3 liters or 2 liters, and the bigger flush would consume 4 to 6 liters. But I was recently going through a research paper which has invented a system which just consumes 330 ml of water. Like, you know, we are really going, innovation is at the peak, you know, and it's the need of the hour, because water is something that we are going to have the next war on. This is a site image where we have, you can see the dual flushing system. You know, I have very funny cases where people just press both the buttons together. And then when you ask them, like, why, what made you press both the buttons? They're like, yeah, just I thought, you know, one is to start and one is to stop, you know. So awareness is something that, you know, we need to create. You might have efficient systems in place, but if there is lack of awareness, these systems, these technologies really fail badly. They fail. So awareness is a key aspect, and that's why we all are here today, to understand what are the systems, what are the best practices. These are aerators. So this reduces your water consumption through taps almost to 60 to 80%, and roughly they cost somewhere around 120 to 200 rupees per piece. So depending on how much percentage reduction you have achieved, you can get maximum 5 points, 3 points in your building water requirement, and 2 points for your landscaping. Moving on to criterion 9, which talks about rainwater harvesting, you can fetch 4 points over here. Now the intent is very simple. I am staying in Navi Mumbai, where you know, the corporation very proudly says that we supply 230 LPD. You know, where the baseline or the norm says that, you know, 90 or 135 LPD is what you need to supply. My city supplies me 232 liters per day per person. Now that's a huge amount, you know. But if I look at Mumbai, which is hardly any at any distance from my place, they are having water shortage, they are having water cuts. Now here the intention is, like, when you're looking at a smaller footprint, we are trying to see how self-sufficient we can be. So here the intent is to ensure that at least you store water of your 2 days requirement. Now, how do we do that? So rainwater harvesting basically can be looked at this way, like you harvest rainwater to recharge your aquifers. Secondly, you can harvest the roof rainwater and store it in the tanks so that you can use that water for your secondary application. And third is, you again recharge your wells so that it becomes a perennial source of water for your own plot or your own site. Now, this is a very interesting system that I came across. Its company is called Furit, and they have come up with this precast modular step well. So it is very simple, and I'm going to quickly show you a video so that you understand the system more in detail. This display. Yes, so that is the system that I was talking about. Quick installation, flexibility in volume and depth of well. One skilled and two non-skilled labors are good enough, and this can be assembled in just few hours. So these are the case studies again from the same company. So it merges really well with your landscape and with your entire setup over there. So when you harvest the rainwater, maximum points that we can get is 3 when you're meeting 75% of the total building water demand over 2 days. And when you're recharging surplus of the water, rainwater that has been harvested, you get additional 1 point. Now here again, non-applicability comes in picture. It's of course, and it's logical that if your ground water table is high, you are not advised to recharge the ground. And so these points become non-applicable to your project. Moving on to criterion 10, it talks about generate resource from waste, which has got 2 points. Now we all know that, once upon a time we used to generate what, 0.38 kgs per person, and now our lifestyle has changed so much. Just on a click we have Amazon and we order products, and with that so much of packaging and so much of waste, that now in metros per person waste generation is almost half a kg. And then if you look at the landfill sites, this is the case. We are just building mountains. So what in GRIHA, in SwGRIHA, we promote is that you recover a resource out of this waste. So you can either have practice composting at your place, or you can, if it's at a little larger scale, you can have a biogas plant. And if you do so, you get 2 points. So here the intention is that zero waste generation through adoption of requisite strategies. And that will fetch you 2 points. Again, there's a non-applicability over here if it's an office building, but obvious I'm not going to generate any organic waste that much, which would want me to install a system. So here these 2 points become non-applicable in an office setup. Moving on to materials. Criterion 11 talks about reduce embodied energy of building, which will give you 4 points. Now, what does embodied energy means? Embodied energy means the energy that has gone in making the product or the material or the technology, right from extraction to its processing, transportation, use, and disposal also. So the entire energy cycle is basically the embodied energy of that material. Now, to give you an example, very interesting example, very close to my house, there is this Govardhan Eco Village in Thane, a little ahead of Thane. So there they had, it's a village, eco village. So they had a lot of infertile soil also. So they decided that let's make the building blocks from this infertile soil. And that is what is called as CSEB, compressed stabilized earth blocks. And when we compare the embodied energy of this CSEB block with a conventional red brick, you will be surprised to see the figures on your slide that the embodied energy of CSEB is just 0.275 megajoules per kg. As against a red brick, it is 72.3 megajoules per kg. So here the intention is that you have alternative material which has got lower embodied energy values. Now, hollow bricks, suppose if you're using local stone, then of course that is going to have lower embodied energy because it is being procured locally, it's being processed locally. So the amount of energy that is going to go inside making of that material is going to be really less as compared to a red brick. Now, even if you have certain technologies or techniques that have been used, which ensures that you are reducing the volume of steel and concrete, is again going to reduce your embodied energy of the structure. Just to give you a very simple example, now this is a study that was done to analyze what is the saving in material if we just change the laying of bricks. Now we have heard of English bond or Flemish bond, right? Which regularly how a masonry wall is constructed. As against, if I have a rat trap bond, look at the percentage saving. I can save 80% brick would be consumed and 20% would be the percentage saving in the volume of the bricks. And in terms of mortar, I will have 39% saving. Now just imagine, just by changing the specification of laying the bricks, I'm having so much of savings, which will indirectly mean that I'm going to reduce the embodied energy of my building. Now here we say that one has to use 100% PPC in the construction. PPC stands for Portland Pozzolana Cement. Now pozzolana means it is an industrial waste which is commonly known as fly ash, which is being added in this cement. So when you use that, you're having you're reducing the the pressure on the landfill site. Otherwise this would have gone to the landfill site. Now there are certain materials that have been approved by BIS to be used in the construction industry, like we have slag, we have fly ash. So these kind of materials, if you use in your structure, in building your bungalows, you're going to have a lesser impact on the environment. So when you reduce your embodied energy of your building by 5% or more, you get 1 point. And if it is about 10%, you get additional 1 point, making a total of 2. And for using only PPC in your structural concrete, you get 2 points. And of course, in your masonry and your mortar also. Moving on to the interiors, we say that you have to use low energy materials, and for that you get 4 points. Now here we talk about two things. We talk about all your interior finishes, including your flooring, your paneling, your partition, your false ceiling. Everything has to be low energy material. And then we talk about the paints also. The paints, adhesives and sealant should be lead free, low VOC, and it should be lead free. VOC stands for volatile organic compound. You must have experienced when you enter a newly painted room, you get a very strong smell of the painted room, right? Now that is the VOC content that irritates your throat and your eyes. Now it has a health impact on you feel dizzy, you feel your head starts aching, so these are ill effects of these materials. So we are promoting materials which are having low energy impact, and also it doesn't affect the comfort of the occupants. Now, what are low energy materials? So any material which has got more than 10% of waste content in the main manufacturing process, that is considered to be a low energy material for us. All stones from India are considered low energy material, and of course the renewable materials like use of bamboo, engineered wood, cotton, and all of this is considered as low energy material. This is a beautiful picture which shows everything. You have got kota stone, you have got engineered wood over there, you have granite stone. This is a refurbished door that you see. Then you again see kota stone over there. Now, how do we know that, which products are green? So for that, what we have done on our GRIHA website, we have got a green product catalog also. So if you're confused at any stage of your construction that which products are actually green, by category, you can select over here. If you're looking for paints, you're looking for flooring, you will get a whole lot of list. We have somewhere around 300 plus products enlisted on our website. So at least 70% of your flooring is low energy, you get 1 point. Then rest of your finishes, if more than 70%, you get additional 2 points. And for paints, you get 1 point. Now moving on to very important aspect of lifestyle, we have the criterion 13, which talks about adoption of green lifestyle, where you can fetch 4 points. Now here we talk about, how do you limit your built up area depending on what kind of structure you're constructing. So if you're constructing a residential place, then per person, your built up area should be between 12.5 square meter to maximum it should be 50 square meters. So here we are trying to say, okay, you have a lot of money, a lot of land, doesn't mean that you lavishly build, but you try and optimize your resources is what we say. Second, we talk about distances to be traveled for your basic services. So we encourage to select a site which is closer to these basic amenities. Like just to buy milk, I shouldn't be starting my car and going like 3-4 kilometers to buy my basic amenity necessities. So here we say that the total expected distance traveled to basic services in a year should be less than 21,000 kilometers. 2,100 kilometers per year, and it is 2,000 for non-residential. And if you prove so, by doing so, you get 1 point. Then in GRIHA, nothing directly to greenness of your building, but on social aspect, we say that for your service staff, you should have a dedicated resting room and a toilet, for which you will get 1 point. And for creating awareness, you will get additional 1 point. Suppose if it's a bungalow and you can't really create awareness, but if you're practicing kitchen gardening is being done, then for that also you get a point. So for built up area that meets a threshold, you get 1 point. Basic amenities within your site premises, you get 1 additional point. Service staff, if you have a dedicated toilet and a restroom, you get additional 1 point, either for environmental awareness or for kitchen gardening that you're doing, you get 1 point. So total, we have got 4 points over here. The last criterion, we talk about innovation. So whatever we have spoke for 45 minutes from now, whatever you do in addition to whatever I spoke, you get 2 points. Now, what can be done? Probably you can have sensors so that you optimize your resources. You can have electrical charging point. You can have e-vehicle. So anything that is not said in 13 criteria can be implemented and practiced over here in criterion 14. Now, this is the whole list of 14 criteria, the maximum minimum points that one needs to get, and the star rating that you can have. Now, the two important questions that we discussed at the start, do we have to do additional work? I'll be honest with you, yes, a little bit. But if you look at GRIHA, it is in sync with the local bylaws, it is in sync with the national codes and the environmental clearance processes. So of course, EC clearance is for bigger projects, but I wanted to highlight over here that we are in sync when you talk about the bylaws and codes. So the first symbol is about of PCMC, Pimpri-Chinchwad Municipal Corporation. They have incentivized GRIHA and SWAGRIHA projects where they give financial incentives to the builder as well as the occupants of the flat. So if you look, there are a lot of synergies over here. Even in ECBC, whatever is mandatory in GRIHA as well. And the initiatives that are taken at central level, state level have also in some or the other way been integrated in the rating system. So we are almost there. If you look at the different sections, we are almost there. It's just a little bit of effort that you need to take to make it 100% green. Now, few people do tell that, the documentation is very tedious, a lot of documents are like required in GRIHA. The answer is we are very logical in doing that. We don't ask you multiple documents, but precisely what you need to submit to prove your claim. For instance, if you're saying that you have used low VOC paint, then you got to prove it to me, right? What you will do, you will submit a purchase order where you say that, okay, look, I have purchased a low VOC paint. And then I got to see the site photographs also that you have used it on site. And lastly, the technical sheet where I should see what is the VOC value over here. So if you see, the red box here says that the VOC value is 50 grams per liter, which matches my threshold. And so you get a point here. So in terms of documentation, it has to be logical, just that you have to prove your claims. Now, do you pay anything extra? So in GRIHA, in SWAGRIHA, we lay a lot of emphasis on cost-effective strategies. So the very logical thing to do when you are designing is to optimize your demand. So if you look at this example that's been shown on your screen, it is about water as a resource. So first you will optimize your demand, right? And then you will install water efficient fixtures. And then to cater to that water demand, you will see how you can offset it through renewable sources, like you are harvesting rainwater in this case. So we lay a lot of emphasis on cost effective strategies. To give you a quick idea of the finances, this is a residential building in Pune which could save 8% of the project costs. 8% reduction in the project capital cost is a huge amount, friends, believe me. And on top of that, they got 30% discount in the premium amount that was paid to the municipality. So this was the incentive, very lucrative incentive for the developer. And for the occupants, they got a 5% discount on the property tax. So it's a beautiful site to go and visit. And of course, these incentives. So in Pimpri Chinchwad and Pune region, you get up to 50%, 50% incentives, discount in the premium amount, and up to 15% discount in the property tax that is paid. So these are the general savings one can have, that you have 30 to 40% reduction in the operational cost, 30 to 50% saving in the energy consumption, and then up to 65% water reduction is possible, 5 to 10% energy saving is possible. So with that note, I would like to conclude my presentation by saying that let's keep nature natural. Thank you so much. This is my contact details. If you have anything right now, I see we are just on time, so we can probably take 2-3 questions. Yes, I'm allowed for that. Wow. So I see everybody attentive over here. So I have a lot of good questions. So these are the answers. All right. Uh, where will where will we use this rating and for what? So this is a rating system, which is a voluntary rating system. So this question has been asked by Mr. Jai Mahesh. So sir, this is a rating system which is voluntary. I don't know from which part of the country you are, but across the country we have different incentives being offered to encourage people to build their homes green. So if you're coming up with a big project or a small bungalow, anything that you're constructing could go for this rating system. And of course, it would add brand value also to what you're doing. Uh, okay, rating system is available for master plan also. So Mr. Jagan is asking me that rating system is available for master plan also. Yes, sir, we do have that. So if you look at on our website, there's something called as pre-certification. So you get pre-certification before you construct anything on site. You can get your entire plan, entire scheme evaluated through us, and beforehand only we can tell you, okay, which star rating you can get and how to go ahead to get higher star rating. So your plan can be evaluated by us, and it's a 1 month process only. So you can just look at our website for pre-certification. If it's a smaller project, then look for pre-certification of GRIHA. If it's a bigger project, look for pre-certification of GRIHA. So there's somebody asking me, what are those two buttons in that sanitary system? So that's what I was saying, that you have, that's a dual flush. So the smaller button is for liquids. So when you go only for the urinal, for urine purpose, you can just press the smaller button. It will do its job. And the bigger flush is for your solids. So now you get systems in market which are 2x4, so 2 liters for the small liquids and 4 liters for the solids. What is the material used to cast step well? So we have a question, what is the material used to cast step well? So it's concrete. So basically it's an Ahmedabad based company. I really like the whole concept of prefabricating your rainwater harvesting structure. So you can just visit on their website and get more details. So there's an interesting question which says that I want to know how much difficulties you face while designing residential building if your goal is to get 5 stars. The intent has to be very clear, and we encourage that, you know, when you are at the designing stage, you should get your project evaluated. Why? Because a lot of things can happen right at the designing stage. As I was showing you the cost effective strategy slide, where, just to give you a simple example, if I have to invite natural daylight in my room, and on the north orientation I have a dead wall, so it's not a very ideal situation, because I'm just blocking the natural light coming in and I'm going to put on artificial lighting, you know, and that's going to increase my project cost. So if these kind of small detailing is taken care right at the designing stage, it's actually easy to get a 5 star rating in Swagriha. Griha, I would admit, it's a little difficult because there's a lot of analysis, a lot of things that you have to do right at the designing stage. I have a lot of questions and I'm getting a hint from the other side that I need to stop. But friends, you can just write to me all of these questions and I'll be really happy to share the answers. And I have also shared my mobile number with you. You can personally also get in touch with me. So with that note, I conclude my presentation. Thank you so much for being with me on a Saturday evening. And I hope you find this useful. Thank you so much.